And welcome back, friends. Welcome to Lesson 6. If you're watching the videos in order and you're watching this lesson on the day after you watched Lesson 4, bear in mind that Lesson 5 is just practice time. Looking for practice time because practice makes perfect. So if you're watching this and you didn't leave a day for practice, then you are a day ahead. Good for you. On today's show, what we want to do is reverse the product rule using a process called integration by parts. We want to reverse the product rule. Yesterday's lesson reversed the chain rule. Today's lesson reverses the product rule, and we do so in the following way. Remember what the product rule was. The product rule says if I'm taking the derivative of a product, uv, I do first times the derivative of second plus second times the derivative of the first, v du dx. Which means that u times dv dx is just the derivative of uv minus v du dx. That's simple subtraction, folks. That's simple subtraction. So now we integrate. We're going to integrate with respect to x. So what's that going to leave us with? It's going to leave us with the integral of u dv over dx dx, the integral of the derivative of uv dx, and v du dx dx. And a whole bunch of shaking going on. So what ends up coming out of this? The integral of u dv is the integral of a derivative minus the integral of v du. This equation is going to give us our skeleton for what we call integration by parts. This is the kind of thing that you want to have memorized. What does it help us to do? It helps us to take one integral that we may not know how to do and express it in terms of some other integral that we might know how to do. The hope is, if we know how to do the second integral, we know how to do the first one. The hope is that the integral of v du is easier to find. The trick is identifying the u part and the dv part. Now, like I said, we are working product rule here. So integration by parts works out really great when you're trying to figure out the integral of a product. And furthermore, it's very good when you're trying to figure out the integral of a product of unrelated things. This is the integral of x times sine x. They are not related. It's a terrible u sub because the derivative of sine x is nowhere in the problem, and sine x is not the derivative of x. So what are we going to do? We're going to say that the integral of u dv is uv minus the integral of v du. And all we have to do is choose our u and our dv wisely so that we can be done. In this case, I will choose to pick as u the part with the easier derivative. Because if I say that u is x, then du is just dx. Really, the derivative of u with respect to x is 1, and we cross multiply. If the entire integrand is going to be u dv, then everything else in the integrand has to go there. Everything else in the integrand has to be the dv part. And then v is just the antiderivative of sine x. That's cosine x negative. Technically, it's negative cosine x plus c, but if you were to carry through a plus c, it gets added and subtracted, it drops out. And so we can use any antiderivative at all for v. So what now is just straight substitution. The integral of u dv, and we have identified u as x and dv is sine x dx. The integral of u dv is u times v minus the integral of v du. That is just straight substitution. And we ask ourselves, is this integral easier to find than the other one was? And the answer is yes, much, much easier. So what have I got? I've got negative x cosine x minus a negative sine x plus a constant, and I'm done. You can check that. You can take the derivative using the product rule. It'll get you right back to where you started. So integration by parts is an excellent way for us to reverse the product rule. This is a classic problem. People do it all the time, all the time. I'm recognizing a product of two completely unrelated functions. And when I see a product of two completely unrelated functions, I think that the integral of u dv is uv minus the integral of v du. I just have to pick my u and my v well so that I can sub in and be done. So I'm going to choose for a u the thing with an easy derivative. Now, technically, yeah, don't jump down my throat. E to the x also has an easy derivative, but e to the x also has an easy antiderivative. And so if I choose e to the x dx to be the dv, it makes for a much cleaner antiderivative than x squared would have. So don't get all on my case about that. Just a reminder, the u and the dv have to cover everything in the integrand. They do. Antiderivative of e to the x is e to the x. So now it's just straight substitution. The integral of x squared e to the x dx is uv minus the integral of v du. And we ask ourselves, is that second integral easier to find than the first one was? Now, I don't know how to find the second one. I don't have an antiderivative in my head for that, but it's 1 power of x smaller. So it's got to be easier. And so I'm just going to say, let's do it again. Let's take this thing that we have so far and just hit the pause button and do another integration by parts on this guy. On this guy. A brand new u, a brand new dv that comes with its own du and its own v. And so we do it again. uv minus the integral of v du. Oh, this is going to be sweet. V du is easy. And so what have we got? X squared e to the x minus 2x e to the x plus 2 e to the x plus a constant. We just run integration by parts more than once. All right. All right. Well, it gets a little hairy now. Gets just a little bit hairy. What happens? What happens when you're not sure what to pick? Like, I know that the formula says uv minus integral v du, but what if the choice isn't quite clear-cut? Both of those have easy derivatives. Both of those have easy antiderivatives. And so I'll just pick u. I'll pick e to the x. Doesn't matter. We're going to get to the same place. E to the x's derivative is easy. Sine x's antiderivative is easy. And so it's just straight substitution. The integral of e to the x sine x dx is uv minus the integral of v du. Oh, I'm going to skip that. V du. And the negative that's inside turns that around. Well, is the second integral easier to do than the first one? Well, no. But it doesn't look harder to do than the first one. So I'm going to try again. I'm going to say integral of e to the x sine x dx is negative e to the x cosine x plus, and I'm just going to pray and give this another go. You're asking, why wouldn't we just reverse the u and the v? Why wouldn't we let u be the trig function this time? You can do that. It just gets you right back to where you started. It's not very helpful. So I'm going to run integration by parts again. uv minus the integral of v du. You may feel free to express your anger at your computer screen, or your iPhone screen, or your tablet screen. You may feel free to express your anger. Because we ran integration by parts twice, and not only do we have something that's not any easier to figure out than the first thing was, we have something that isn't any different than the first thing was! Wait a minute. We have an integral that isn't any different than the first thing was. And so that means that if I were to add this to the left side, my left side would be 2 integrals of e to the x sine x dx equal to negative e to the x cosine x plus e to the x sine x plus a constant. And so to get what I want, I would just divide by 2 and put a box around it. Oh, that's just flat out mean. I could run integration by parts twice and then have to do algebra. We don't do algebra. It's a calculus class. Hey, a couple of things that look like integration by parts problems to no one. Absolutely no one. That doesn't look like an integration by parts problem at all. But it is, and I can show very quickly that it is. And these are classic. These are the things that just pop up on calculus tests just so they can say that they asked a classic question. What if u is ln x, and then dv would be dx? Well, in that case, the derivative of natural log x is 1 over x. And the antiderivative on the right side, well, that's pretty easy. And so now we're just going to do straight substitution. The integral of u dv is uv minus the integral of interesting. Interesting, isn't that? Huh. uv minus son of a gun. Son of a gun. So it doesn't look like an integration by parts problem because you don't think of that as a product. You don't think of ln x times dx as a product, but it is. It is. And then, and then, what about that guy? I know his derivative, I just don't know his integral. So, well, we'll give it a shot. That worked before. I got the v part. I just have to remember what the derivative of inverse sine is. And the derivative of inverse sine is 1 over radical 1 minus x squared. Well, what does that mean? That means that the integral in question for me is uv minus the integral of v du. Oh, don't even. Don't even. See, what ends up happening is that you get an integral where the derivative or constant multiple thereof of something in your denominator is in your numerator. And so now you're thinking U substitution from lesson 4. The problem is I don't have a -2 in my integrand. And so I just have to randomly say, oh, look, there's a -2, but I have to balance that out. And so what do we end up with? We end up with x inverse sine of x plus 1/2 integral of u to the -1/2 du. And that, let's see, antiderivative of u to the -1/2 is u to the +1/2 divided by 1/2. That's just square root of u plus a constant. Golly! Golly! Not the kind of thing I would memorize. It's not worth it to memorize that, but it's very much worth it to know how to come up with that integral using integration by parts. All right. Thanks, everybody. We'll see you tomorrow.